Okay, so that's the specifications around the transmitter. Let's talk about some of the key RF specifications for the receiver and how they're measured.
Right, same as the transmitter really. Performance specifications for a receiver are separated into the desired and the undesired aspects. Basically, what is the minimum signal that can be received and the information still be extracted understandably versus what other signals can be received at the same time without interfering with the reception of the desired signal. So sensitivity is our first spec for the receiver. That's the sort of the desired performance. It's the minimum received RF signal level that results in an understandable audio output quality. It's usually quoted in dBm, and a smaller number is best. Minus 120 dBm, for example, is better than minus 115 dBm. There are two types of sensitivity measurement, and you need to know the difference between them. Static sensitivity is the test measurement simply to prove compliance against ETSI or FCC regulations. Dynamic sensitivity is probably the more important one, which is the minimum received signal level actually required in a real system under real conditions. Better sensitivity performance reduces system cost because it just means greater coverage and therefore a smaller number of sites.
Okay, so again, like you said, there are wanted ones and unwanted ones. So let's talk about the unwanted ones.
So the first of these is adjacent channel selectivity. That basically is a measure of how much stronger a signal in the neighbouring channel can be compared to the weak signal in the desired channel before it starts to degrade the communication performance. Selectivity is usually quoted in dB. A larger number is best, so 90 dB selectivity performance is better, for example, than 75 dB.
Okay.
So a receiver with better adjacent channel selectivity will allow a radio operating on an adjacent channel to get closer to the site again before it starts to suffer interference. In short, receivers with better adjacent channel selectivity will contribute to a more reliable, robust system. The selectivity of a receiver is also very closely related to the adjacent channel power output from a transmitter.
Okay. So the next specification is intermodulation. Could you explain that one for us?
Yep. When you get many strong interfering signals, which is probably the more normal case, you don't just get one as per the selectivity measurement. There are often several strong interfering signals, and quite often, depending on their frequencies, they can actually mix and produce intermodulation products that swamp the weak wanted signals you're trying to pick up. So the intermodulation performance of a receiver just really is an indication of how much stronger the unwanted signals can be before they will degrade communication performance.
Okay.
Again, it's usually quoted in dB. A larger number is best, so 85 dB, for example, is better than 65 dB. At fixed sites, so strong signals from co-located transmitters can produce intermodulation products at levels that can deafen site receivers. And what that means is distant terminals, so mobiles and portables out in the field, will be unable to reach the site, therefore wouldn't be able to communicate. Large, costly cavity filters can protect against this. So base station receivers with better intermodulation performance reduce the quantity, size and cost of those external filters that are required.
So now that we've talked about what the different RF performance specifications mean, hopefully this will help you as you compare different specification sheets from Tait or our competitors to see which one has the advantage in particular situations. So last question, Ian, what are the benefits for a customer if they choose a system with better RF performance? So not just, well, you'll get better RF performance, but how does it actually benefit the users and the managers working on this system?
The really key point here is that radios with better RF performance like Tait are often more expensive to buy than their lower performing counterparts. But buying the more expensive, better performing radio equipment with better performance specs actually results in a lower overall system cost. Because better base station and terminal RF performance means less sites are required, and the sites are the major cost in building the system. Better base station RF performance means less complex third-party combining equipment is needed, and so further reduces the costs. In other words, less third-party equipment on the sites. Better terminal and mobile RF performance means terminals will carry on working further away from the site. So in summary, having better performing RF equipment will mean less sites are needed to actually cover the area. You will need less equipment on those sites to actually make it all work and not interfere with other co-located systems, and you will get improved reliability from the system.
Okay. Well, thank you very much, Ian. Hopefully that was helpful for you guys, and now you understand a bit better the RF performance advantage that Tait can offer you.